Shazam! Mr. Miller's here. Hey, at Clark High School. Today's Monday, November 13th. And what I'm going to do now is show you guys some videos, video examples on how to factor quadratics, which we've done in the classroom already, but I thought giving you guys some examples through a video would be good too. So let's take a look at our first example. And it says to factor a squared minus 10a plus 9. All right, what we want to do here is we want to take this problem that has pluses and minuses in it, and we want to make it more of a multiplication problem. To do that, we first have to look at our quadratic and ask ourselves, is it naked or is it dressed? If it's naked, that means the letter squared part is going to be bare. There's going to be no number written in front of that part. And this is going to be a naked quadratic. Naked quadratic is nice because it's generally quick to factor. We need to find two numbers that multiply to the back end, but those same two numbers have to add sandwiched in the middle. And what's sandwiched in the middle? Negative 10. Now, if you're still struggling with trying to find the numbers that make the magic happen, the numbers that would multiply to 9 but also add to negative 10, I did show this in class, but let me do it again here right quick. Think of all the ways to multiply whole numbers 9. We could do 1 and 9, and we could do 3 and 3. And there's no other way to multiply whole numbers to get 9. This is the only combination, the only combinations we have available to us. Now, if I ignore this minus on the 10, it almost looks like that maybe 1 and 9 is where I should focus my attention, because I know that 1 plus 9 is 10. What we want, though, is we want to add to get negative 10. If 1 plus 9 is 10, then negative 1 plus negative 9 is going to be negative 10. And those are the two numbers that we want to use, negative 1 and negative 9. Negative 1 and negative 9. Okay, now, sorry, I had a blonde moment there. I was freaking out because I thought I wrote the problem wrong. I thought it wasn't going to work out. I'm sorry, I'm tweaking a little bit today. All right, actually I'm tweaking a little bit more than usual. Need food. Once we find the numbers that make the magic happen, we have to decide, all right, how is this going to break up now? We know that a squared means I have a times a. A times a is a squared. Each of these a's is going to get dropped into its own set of parentheses. You'll notice that we have two spaces remaining, and what I need to do is to fill those two spaces with what? With these numbers that we found to make the magic happen. And I'm just going to go straight down, but if I wanted to, I could put negative 9 here first and then put negative 1 there. It doesn't matter. It's the same answer as doing a minus 1 and then a minus 9. And there you have it. This quadratic is factored, and we are done. Final answer, a minus 1 times the quantity a minus 9. Now, let's do a slightly harder one, and let's do one where we have a number in front of our letter squared part. Number in front of our letter squared part means what? It's not naked, but it's dressed. There's a number specifically written out in front of that g squared, and it's not 1, it's something other than 1. So this is a dressed quadratic, and to handle that, we first have to multiply front end times back end. What is 4 times negative 7? Say it out loud. If you said negative 28, nice job. That's correct, negative 28. We're going to need two numbers that multiply to negative 28. But those same two numbers have to add to what's in the middle, and what's in the middle? Positive 3. Okay, now take a moment to the video and try to figure out what two numbers multiply to negative 28, but those same two numbers also add to positive 3. The two numbers that make the magic happen, what are they? If you said 7 and negative 4, give yourself a cookie, because that's correct. Nice job. Okay, now that we have the numbers that make the magic happen, what time is it now? It's not snack time, it's not nap time, it's not tea time, it's table time. And you guys have been doing a really good job adapting to using this table. I know at first a lot of people didn't like it, but you're starting to come around and that's good. All right, first box is for the first piece of our quadratic, 4g squared. Last box, negative 7. And then along this diagonal, we're going to fill in these two boxes with the numbers that we found to make the magic happen. And the order doesn't matter, meaning I could put 7 in this upper right box, or I could put 7 in this lower left box. It doesn't matter. And what do we have to do to those two numbers? You remember from class what I said we have to do? We have to attach the variable to these two numbers. And just very quickly, the reason for that is if I combine these two things, 7g and minus 4g, what do I get? 7 plus negative 4 is 3, 3g. That's exactly what we have in the middle of our quadratic. In other words, everything that we've written in this box is really the same as what we started with here. We've just put it in a slightly different form. All right, let's factor out GCFs now. GCF along the top row. So I'm going to do this very quickly, and if I'm going too fast, you can always backtrack in the video and watch it again. But I don't want the video to be too long, so I'm going to have to kind of talk fast. What I'm showing is how we're getting the GCF. Now, I've shown you guys in class that if you're able to just get the GCF without doing these charts, which can be time consuming, that is what you should do, as long as you do it accurately. But if you're still struggling with finding, what's the GCF of 4 and 7, you can always fall back to doing these charts on the side. And what we want to do is find all the ways to multiply to get 4 using whole numbers, 1 and 4, 2 and 2. All the ways to multiply to get 7. 7 is prime, and its only factors are going to be 1 in itself, 1 and 7. Now, compare those two charts. What's the biggest number that's the same in both? 1, right? The GCF of 4 and 7 is 1. Whoops, I should use, okay, 1. Now, how do we handle these letters? The letters, I'm going to do this on the side also. We have g squared, that's g times g, and then the second just a g. Well, how many g's do they have in common? All right, most they have 1 g in common. The reason why it's not 2 g's in common is because the first box has the second g, but the second box, sorry, let me point to it. First box has 2 g's, the second box only has 1 g. We've already used one of the g's in the first box and one of the g's in the second box to make this pair. Now this g would be all by itself, but there's no g's in that second box anymore in order to pair it with. So in other words, how many g's do both boxes have in common? A single g, g to the first. Now that was a long explanation to get that answer. So here's a faster way. Look at your exponents. This says g to the second power. That says g to the exponent, g to the first. Okay, now let's do the GCF of the bottom row. And we have 4 and 7 again, ignoring the signs. We just found the GCF of 4 and 7 is 1, but now we need to worry about what's the sign. And in order to determine the sign, you always take the sign closest to where you're factoring, the box closest to where you're factoring. We're factoring the bottom row. The box closest to us in the bottom row is the minus 4g. Its sign has a minus, which means our GCF needs to be minus also. Okay, now let's take a look at the first column. What's the GCF of 4 and 4? Okay, well, here's a tip. If you're comparing essentially the same number, ignore the minus here for now. We're looking at 4 and 4. The GCF is that number because the biggest number that's going to divide into 4 and 4 evenly is itself. That would be 4. Now, Algebra 2 peeps, how many G's can we take out of this first column? 2, 3, 5, a million, 1, how many? Compare the exponents. We have 2 G's here and a single G there. The number of G's they have in common is a single G, smaller exponent. Take out G. Last column, what's GCF? If you said 7, nice job, that's correct. The biggest number that's going to divide into 7 and 7 is 7. And we can't take any G's out of the last column or the last row because you'll notice that the first box has a G, but the second box has no G. There are no G's in common to take out. And same thing with the last column. This box has a single G. The box underneath it has no G's. Oh, I wish I had some G's. I could make some money. But that's neither here nor there. Sorry, I'm getting sidetracked. What's the sign of this 7 going to be? Positive, right? Because the box closest to us is positive. And what we get along the top and along the left is how this original quadratic factors. Okay? So to recap, if it's dressed, multiply front. Find the two numbers that make the magic happen. Multiply to negative 28, but add 3. Make your table, take out GCFs, and what we get at the very end here is how this thing factors. It's going to factor as big finish, 4G plus 7 times G minus 1. Okay, and there's no reason to get hung up about does the order matter. It doesn't. I could have written G minus 1 first here, and then in the second parentheses put 4G plus 7, and it's the same thing as what I have written here. They're equivalent. They mean the same thing, even though they're written in a different order. All right, guys, I'm ready to go home. I'm pretty tired right now. Good work today in class. Keep up the good work. Appreciate you taking the time to watch this video, and I will see you later. Adios. Bye.